Welcome to the Tech Talks Daily Podcast, where you can learn and be inspired by real-world examples of how technology is transforming businesses and reshaping industries in a language everyone can understand. Here is your host, Neil C. Hughes.
Welcome back to the Tech Talks Daily Podcast, where I'm excited to get someone from tech royalty on our show today. Bram Cohen is an American computer programmer, best known as the author of the peer-to-peer BitTorrent protocol, as well as the first file-sharing program to use the protocol, which was known as BitTorrent. And I have a sneaky feeling that every single listener to this podcast has used BitTorrent in their tech past. Am I right? He is also the co-founder of CodeCon and organiser of the San Francisco area P2P Hackers Meeting, and was the author of Codeville. And he was also featured in 2005's Time 100 Most Influential People list. But enough looking backwards. We only like to look forwards, don't we? So how is he looking to revolutionise the world here in 2019 and beyond? Now, he's currently working with the world of blockchain and cryptocurrencies and a company called Chia. The Chia Network is a decentralized open-sourced global blockchain, which is less wasteful, more decentralized, and more secure. It was inspired and similar to the Bitcoin blockchain, but in Chia, the resource is not computing power, but disk space. So to achieve this, the proofs of work used in Bitcoin are replaced with proofs of space. So disk space becomes the main resource. And that combined with proofs of time to come to a decentralized Nakamoto-style consensus that validates the transactions. Intrigued? Would you like to hear more about why Chia is focused on creating a better Bitcoin? And also curious about exactly what problems they're setting out to solve? Good answer. Hold on tight so I can beam your earballs all the way to the US so you can join me in conversation with Bram Cohen. So a big warm welcome to the show, Bram. How are you doing today?
I'm good. I'm drinking my coffee, waking up.
So I've heard somewhere that you refer to what you're doing as Bitcoin adjacent. And we're going to have people listening inside and outside of the blockchain and crypto community. So can you tell me a little bit more about exactly what that means?
Yeah. So what I'm doing is building very much on top of Bitcoin. It's kind of part of the same project of making cryptocurrencies work. But I'm not doing it within Bitcoin because it's actually hard to add anything to Bitcoin. It has a very large legacy set of things in it, which are very hard to change. And there are some things that I want to make better that really require just making something totally new, and some things which you can in principle add to Bitcoin, but Bitcoin core development is rightfully very conservative and doesn't want to go making like massive changes quickly. So but everything I'm doing is fairly directly off of this is what Bitcoin does, and then getting a good understanding of that and figuring out improvements and how you would do it if you were redoing everything from scratch.
So how is Chia different from all the other cryptocurrencies out there?
There's two kind of categories of improvements that we're making. One of them is in the consensus algorithm, and the other one is in the on-chain programming environment. So for the consensus algorithm, we are using proof of space instead of proof of work. So Satoshi Nakamoto in the Bitcoin white paper said that his goal was one CPU, one vote. And that has essentially failed. That what we see is not one CPU, one vote at all. What we see is custom hardware and the primary cost being power rather than the cost of the hardware. Satoshi had this idea implicit in how he described the future that the primary cost of mining would be the amortized sunk cost of building CPUs, which are mostly sitting around not doing much of it. And that isn't how things have worked out at all. Custom hardware can dramatically outperform, and there's tremendous power costs to these things. So where you're getting the power matters a huge amount. So, but there is, in principle, something that works a lot better, which is storage. Storage is all just storage. It doesn't really matter the details of how it works or anything. There's no customized storage that works different from something else, bits are bits. And there are proof of space algorithms which don't require lots of power. You have a single setup phase at the beginning, and thereafter it's just these really quick lookups in order to do your proofs of space. So the idea is, instead of one CPU, one vote, it's 1 gigabyte, one vote.
And of course, one of the big topics at the moment is all around adoption. So a question I've got to ask is, how will Chia be used and by whom, and what kind of problems does it solve, just to understand where it will fit in the landscape?
Cryptocurrencies in general, the thing that they're good for is being money. People have all kinds of ridiculous notions of doing, I don't know, health records on the blockchain or something. But what they're actually good for is being used as money. And so the idea is to make it more useful as money. And, the big problem that people actually have with Bitcoin in practice is that transacting in Bitcoin feels kind of like carrying around huge wads of $100 bills. And that's a bad thing. People don't want that. So there's this question of how can you improve on the on-chain programming environment to enable smart transactions that actually make sense. A lot of the smart transactions that people have out in the wild, say, first off, people hardly use them, but it's basically gambling and games, and those I view as kind of silly. And the one that's actually used is colored coins, which is something at least. But there's tremendous demand for things like, multi-sig is one thing. People definitely use that. But also having things where you could have like a wallet where there's a recovery mechanism for it. So if you lose your king material, you can go back to your recovery key and use that to regain access to your wallet. But your recovery key is kept in a backup place that's less likely to be lost, but possibly more likely, or at least independently likely, to get stolen. And so it's designed so that if someone attempts the recovery process, but you still have access to your secure keys, you can stop that and claw it back again. So that's an important use case. Another thing is like having a wallet which can spend, but all of its attempts at spend get escrowed a little bit. And there's another entity that can notice if there's an attempt at an unauthorized withdrawal and claw it back if that attempt is made. Another one is to have a wallet which has rate limiting in its spending. So it can spend at some rate, and at any time there's another key that's kept presumably in cold storage or by somebody else that can claw back the entirety of funds in the wallet. The idea being there is that you have, your hot and cold key, and if your hot key gets compromised, you wish to be able to stop it from taking all the funds in the wallet. So you're limited in the amount of funds that can be taken out by the amount of time that's passed between when the compromise happens and when you notice and stop it. So that's the kind of flavor. There's more. I can go on. Also, colored coins is another thing. But that's the kind of flavor of smart transactions that we're aiming to build. And something I'm very proud of. We really started with just like taking Bitcoin and what's called the UTXO model, this data model that Bitcoin has, and staying within that and doing just very simple, basic block and tackle, improve this, improve that kind of things, all of which don't seem that important on their own. But when you get enough of them together, it really adds up to something very powerful. And it turns out there's an awful lot of these things that people thought you really can't do in the UTXO model that you can if you do just enough little cleanups everywhere. So it leads to this thing where all of these smart transactions don't have like custom opcodes for each of them. They're all just written from scratch in this very general purpose environment. So there's no need for like painstakingly adding new opcodes for each use case that you want in the future. And then they don't really support it, right? They just kind of support it reasonably most of the time. But this allows just people to build whatever they want and without needing to add any new extensions onto the on-chain programming language. So we're in the process of building this now and building some of these reference smart transactions for it, and we'll be making that available soon.
And you've enjoyed a fantastic career in tech. And every man needs a reason to jump out of bed in the morning and have a purpose. So from a personal standpoint, why are you passionate about creating Chia and the Chia Network? What is it?
There's been a lot of just really interesting problems to work on. That there's all this stuff where I feel like I'm actually accomplished something. I'm building something that has a real utility in the world, that actually it clearly does a real thing. Thing with cryptocurrencies today is they work, right? They do this really amazing thing, which is they succeed in having a secure distributed database, which was thought to be impossible. That sounds totally oxymoronic. How can you have a secure distributed database? But they actually do it. Now, they don't do it very well, but it's miraculous that they do it at all. And it's that they don't do it very well. That means there's a lot of opportunity to really improve on things.
And just to get everybody on the same page here, can you just go into a little bit more detail about the differences or the main differences between mining and farming?
So like I said, the bottleneck in what you do is, instead of being computation on a CPU, instead of doing like SHA-2 hashes, you do this other kind of thing that's proofs of space. But it's still Nakamoto consensus. It's still that if you and I get into a discussion of what is the current state of this secure distributed database, the way we settle it is we look at the histories that we have, and one of them is going to weigh more than the other one, because roughly speaking, more resources went into building it. And we settle our argument about what the current state is by whoever claims to have a heavier one sends their diffs to the person who has the lighter one. And the person who had the lighter one goes, oh, yep, that has a heavier weight. I'm going to go with that. And that's how you very quickly achieve consensus. So that is unchanged. We're definitely doing that. We're not doing like proof of stake or any of this crap that people talk about. We're sticking with this fundamental core idea of having Nakamoto consensus, which actually is the thing that makes Bitcoin really special, where a lot of these things people talk about doing are actually going backwards. They're going to things that failed before Bitcoin. This comes with a number of caveats. I'm not the first person to get this idea of, hey, let's use proofs of space. There are a lot of very just technical issues with trying to make proof of space work well. The problem is the thing that's good is also a headache. You've made it so that it doesn't cost anything to move the blockchain forward, which results in grinding attacks. People can go, okay, well, I'm just going to create, a million alternate versions of this and just pick out the one that works out best, because it costs very little to do this operation going forward. So you wind up having this very deep technical issue of how do you stop these things? And I had this very high level idea. And my big idea here is, let's mix in proofs of time, what are more technically called verifiable delay functions. But the idea is we're going to have a proof of space and alternate that with proofs of time. We're going to go back and forth, alternating back and forth between them. So the way it really works is there's a whole network of machines, and someone makes a block. In response to this block, everyone goes and finds the best proof of space that they have. The proofs of space get distributed. The best one wins. Now, the way the next block is made is a proof of time is now running off the challenge from the last block. And the number of iterations this proof of time is going to have to run for is dependent on how good the proof of space is. In some sense, every single one of these proofs of space people make can be used to make the next block. It's just better ones are going to take less time. So there are these time lords out there running the proofs of time. And after the amount of iterations necessary to fully validate, the best proof of space gets done, that then completes the block, and the hash of that is the challenge for the next block. So you have a few very, very fast time lords running out there. You have all these farmers who are sitting around twiddling their thumbs most of the time, doing a bunch of lookups every once in a while. And you have a few time lords that are running like super fast hardware that just do proofs of time. And there's like a handful of those. But the deal with proofs of time is you pretty quickly start hitting these physical limits of how fast things can run, and there's no direct reward for doing it. So it's this kind of just adjunct thing that happens where proof of space is the real star of the show here. And yeah, there's that alternating back and forth that happens. But this is in some sense a sideshow to everyone using it. It matters a lot if you're participating in the consensus algorithm. But if you're just using the thing, what you see is there are full nodes and there's a wallet protocol, the equivalent of SPV protocol, and there's transactions, and all that stuff is pretty normal.
And we do have people listening in 165 different countries today. And if any of those people listening have a laptop with a little extra storage on there, can you tell me how they can get up and running and start farming?
Well, they can't today because we're not shipping today. We are working towards having a functioning testnet. And, these are the way these things go. You ship like your first alpha testnet is very alpha because the idea is to just get something up there and running. So like our first testnet isn't even going to have transactions in it. It's just going to have a consensus layer. But what we do have today is there's a library for doing proofs of space that you can download and run and play with. And we have a proof of space implementation competition, which is currently underway. It's a programming competition for best implementations of our proof of space primitive that we invented by several different metrics. And we're going to be giving out a total of $100,000 in prize money as rewards for that competition. That one ends on October 9th.
And moving forward then, when everything is up and running, how much can listeners expect to earn as a farmer? I know it's a pretty big question, but is there any ballpark kind of figures there?
Well, it's a little hard to say.
Yeah.
It's very dependent on a few things that I have very little direct control over. So one thing it depends on is the price of Chia. So I don't know what the price of Chia is going to be. And another thing it depends on is how much storage people are devoting to the whole thing out there in the network, because there is a work difficulty reset like there is in Bitcoin as well, that the more resources are thrown at it, the less rewards per resource that you get in exchange for doing this.
And can you tell me a little bit more about Chia's business model too? I mean, do you plan to do an ICO, for example, or is there something else?
We're not doing an ICO. We're going to launch the network and kind of take it from there. But it is going to be based on us having a big pre-farm. So some amount of Chia we're going to have ourselves. The plan longer term in terms of actually having a revenue generating business is to have a Chia lending business. We're going to be creating liquidity and actual commerce happening with Chia and lend it out and get returns off of that, just as like a normal kind of a thing that people do, is lending stuff.
And obviously these things take time, but we are living in an age of instant gratification where everybody wants updates continuously. But what progress have you made so far in establishing Chia as a new cryptocurrency?
Well, a lot of the work has been around building it, right? Because you can't get people to use it if you don't have a product. So we've been putting most of our resources into engineering. And like I said, the whole plan was to use proofs of space and proofs of time. And so that required at the time I came up with this idea, there weren't actually proofs of space or time that met all the criteria that we needed. And also there's a bunch of subtle details about how to fleshing out all the details about how to stitch them together. Some new stuff needed to be invented there. So we've since then invented all three of those things, which is a big relief because you're really not supposed to have invent new math here in your development roadmap. Really not recommended. We've done two proof of time implementation competitions. Those are both done. We're doing our first proof of space implementation competition. And we are building our on-chain programming language and reference smart transactions for it. And we are building our actual protocol and stuff. And so the plan is to, by the end of the year, have two things out, a Ledger Sim, which has our on-chain programming, a early version of our on-chain programming environment, and reference smart transactions, and our testnet, which is going to be a very alpha testnet, but is an actual working thing that you can run that has consensus go forward.
Now, speaking to you today, obviously I've broken one of the main rules of any crypto podcast, and that's we've not discussed roadmaps, partnerships, or Telegram communities or anything like that. We can save that for another day. But for people that would like to find out more about things like that and the kind of progress that you're making and what you're building there, can you point people in the right direction of where they can find out more information about Chia?
Well, our homepage is at chia.net, and we have Keybase channels that people can come discuss in.
Excellent. Well, I'll add all the links to the blog post that will accompany this podcast, just so people can find that nice and easily. But more than anything, a big, big thank you for coming on and joining me today. I really appreciate your time. Thank you.
Thank you. Have a good day.
So a big thank you to Bram for coming on the show and talking about Chia today. And I must confess, I do wish we had more time to talk about the BitTorrent days, but we'll hopefully get him back on the show and speak with him again next year and find out a little bit more about his past and also the future of Chia and get a bit of an update on that. But right here in 2019, Chia is the first enterprise-grade digital money. And Bram is building the Chia Network to improve the global financial and payment systems. Essentially, Chia is using a new consensus algorithm for a new blockchain called proof of space and time. And it's easy to see how Bram Cohen is described as the world's best network protocol engineer alive. And compared to other cryptocurrencies, Chia is vastly less resource intensive and will have improved security due to its far more decentralized blockchain. And Chia is also adopting more modern cryptographic tools to enable richer smart transaction capabilities. And additionally, Chia will use its strategic reserve to ease the volatility of the coin, which can only be a great thing too. And finally, I must point out that the deadline for the proof of space competition with $100,000 total prize money is coming up quite quickly. That's on October the 9th. So we did talk about it in the interview. If it's something you wanted to learn more about, I'll put a link on my website on the blog post that accompanies this episode over at techblogwriter.co.uk. And if you just hit the podcast menu, you'll find more info on today's episode, and I think there's not 970 other episodes too. But if you have any other comments, insights, or if you'd like to join me on the podcast, simply send me a quick email at techblogwriter@outlook.com or tweet me at Neil C. Hughes. But we're out of time once again. Keep your messages coming in as we race up to 1,000 interviews with tech leaders all over the world. And hopefully you'll join me again tomorrow with another great guest. So thanks for listening wherever you are. And until next time, don't be a stranger.
Thank you for listening to the Tech Talks Daily Podcast with Neil C. Hughes. Remember, technology works best when it brings people together.